standard form of a quadratic is y equals ax squared plus bx plus c. So it's the multiplied out version of the quadratic. The vertex, the x value of the vertex can be found by taking the opposite of b and dividing that by 2 times a. B is the number in front of the x. A is the number in front of the x squared. It's not a really complicated equation. Negative b divided by 2a.
Wait, so b we're just like turning it into a negative? Like the opposite?
Yes, we're taking the opposite of it. Yes. Yes. Now, the key feature that the standard form equation gives us is the y-intercept. When I look at this equation, I should see that if I plugged in 0, what would I get? No. If I plugged in 0, I would get C. Right? Because this would be 0, and that would be 0, and I just get C. So my y-intercept is given to me 0, comma, C. The x value is always 0 for a y-intercept. I erased my equation. Now I gotta go find it again. Negative 2x squared minus 8x plus 1. Okay, so my equation, we're gonna graph y equals negative 2x squared minus 8x plus 1. Can you tell me whether this quadratic should open up or down? It should open down because a is negative. Just like vertex form, just like the absolute value functions. Okay. What is my a? My a is negative 2, the number in front of x squared. What is my b? And what is my c? 1. Okay, so if I'm finding my vertex, x equals negative b divided by 2 times a. I have negative 8 divided by 2 times negative 2, which is positive 8 divided by negative 4, which equals negative 2. So the x value of my vertex is negative 2. In order to find the y value of my vertex, I will have to plug it back in. Okay, so we know the x value of our vertex. We're going to make a table with that number in the middle. Okay? Just like we did yesterday, except for we don't know the y value. So negative 2 is in the middle. You can. I'm going to do it after I make my table. Yeah. You can do that now or when you make the table. I'm going to make the table and plug in the negative 2 as I go. Okay? So what numbers am I going to put around negative 2 in my table? Right, so we're going to make our little number line, right? Just like we did yesterday. Make a number line of 5 numbers with the vertex in the middle. And now we're going to plug them in. So what do I get when I plug in 0? I get C, so I get 1. Okay. I'll show you. I'll prove it to you. Negative 2 times 0 squared minus 8 times 0 plus 1. 0 minus 0 plus 1 is 1.
Negative 4 will still be 1.
What?
Negative 4 will still be 1?
Negative 4 will also be 1 because it's symmetrical. Right? So this will also be 1 because here's my vertex, right? My vertex is here. Now let's plug in negative 1. Negative 2 times negative 1 squared minus 8 times negative 1 plus 1. What am I going to do first?
The exponent.
The exponent. I'm emphasizing that because that is the number one mistake you make when evaluating these is not doing the exponent first. Okay, people like to multiply because they see parentheses, and that's not correct. There's nothing to do inside the parentheses. So that's negative 2 times 1 minus plus 1, or plus 8, because negative 8 times negative 1 is positive 8, right? Plus 1? Negative 2 plus 8 plus 1?
7.
Right, 6 plus 1 is 7. So I get 7. And what other x value will also have a y value of 7? Negative 3. And then plug in negative 2. You have to plug in an extra number. So negative 2 times negative 2 squared minus 8 times negative 2 plus 1, because that's negative 2x squared minus 8x plus 1. Again, the exponent comes first. So we get negative 2 times positive 4 plus 16 plus 1. Negative 8 plus 16 plus 1. 8 plus 1 is 9. So my vertex is at negative 2, negative 9. Positive 9. Yeah, sorry. And now we can graph it. Bring in my little coordinate plane here. My vertex is at negative 2, positive 9. I have an axis of symmetry through that vertex still. The graph, still a parabola, still has an axis of symmetry. Your domain and range are the same. What did I get when I plugged in negative 1? We got 7. And negative 3 was also 7. And 0 was 1. And negative 4 was also 1. One of the things I saw in some of the homework assignments when your graphs looked a little funky is you didn't actually plot this point right. Like it would be here in the same x value. So just be careful to make sure you're plotting your points right. And connect it. Here's your graph. All right. Questions?
Oh wait, we have to write the domain and range, or we good?
Yeah, let's write the domain and range. Why not?
Sorry. All the numbers and y is greater than or equal to, and less than or equal to.
Y such that y is less than or equal to 9? Because the y values are at 9 and below, because 9 is a maximum, right? Always all real numbers for any quadratic.
Are we going to always do domain and range?
Yeah, we're going to do domain and range on all the functions. And it's just good practice, because then if we ask you a question about domain and range on the test again, it's refreshed in your memory, right? Okay, so our next equation. Oh, yeah.
Ew.
Okay, so how about a trick for making the fraction part easier?
Times only by 2.
No, you cannot times the whole equation by 2, because then you still have 2y. That does not work. That only works when you're like solving an equal to a number. It's not equal to a number. Okay, so what is the equation for the x value of the vertex? X equals what?
Negative b over 2m.
Okay. I like to write it down every time. You write it down every time for every problem. You'll have it memorized after not that long. Right? So write it down and then plug it in. What is my A? 1/2. What is my B? And what is my c? Negative 2. So negative 4 divided by 2 times 1/2. Which is 4 over what? No. 1. Which is 4. Right? 1/2 times 2 is 1. 4 over 1. Half of 2 is 1? Is that where we're confused?
No, but you got.
Right here. B is negative 4. So negative 4. That becomes positive. 2 times A, this is A. So 2 times 1/2 is 1. And 4 divided by 1 is 4. And make our table. We're going to put 4 in the middle. Now, here's where you want to not deal with fractions. My denominator is 2. So if I count by 2's in my table, then I will get even numbers and my fraction will go away. If I use odds, then I'm going to have to deal with the fraction. So I can pick, instead of 3 and 2, if I don't want to deal with the fraction, I'm going to do 2 and 0. And 6 and 8. Now, is it wrong if you don't think about that and you just plug in 3 and 2? No. You're just going to get different points, and that's okay.
You said odd for fractions and evens for...
So if I plug in an odd number here, if I use 3, I'm going to get an odd number times the fraction. It's not going to be a whole number. So I'll have a fraction in there. And that's because my fraction is 1/2. If my fraction was 1/3, I would skip 3 numbers from my vertex. And then every third number is going to give me something divisible by 3.
So it's always going to be based on the bottom line?
Yeah, based on your denominator. Okay? Or you just plug them in and add and subtract your fractions. There's ways around the fractions, that's all I'm saying. So what do I get when I plug in 0? Negative 2. Okay, 0, when I plug in 0, I'm always going to get my constant c, negative 2. That's going to save me some time to have 0 on the graph. 0 doesn't have to be on every graph. And sometimes if your vertex is at 8, 0 is going to be really far away, and it's going to be a really big number, and it doesn't make sense to put that on your graph. But other times, it does. So, we're going to plug in x equals 2. 1/2 times 2 squared minus 4 times 2 minus 2. What am I going to do first? Do my exponent first. 1/2 times 4 minus 8 minus 2. 2 minus 8 minus 2 is negative 8. Negative 6 minus 2, negative 8. And then plug in 4. My vertex. 1/2 times 4 squared. Minus 4 times x, which is 4, minus 2. So that's exponent first, 1/2 times 16, minus 16 minus 2. Yeah?
Yes.
8 minus 16 minus 2,
Negative 8 minus 2. I did it as a
negative 10.
Get it right, subtract 2.
Okay? So, what can I say about the y value for 6? What's it going to be?
Negative 8.
It's going to be negative 8 because it's the same distance from the vertex, right, as the 2.
So in order to do that, everything has to be by 2, correct?
Yes. Yeah, you have to be consistent, right? They have to be the same distance from the vertex. And I'm going to do an example where your table might not show symmetry next. Why? Because if... All right, now we're going to graph it. Oh, I already have this. I already have this one. Okay. These are all negatives, so at 4, we're at negative 10. Right? That's my axis of symmetry is coming through there at negative 10. Sorry, negative 4, positive 4. Oh my gosh. And 6, negative 8. And 2, negative 8. And it was 0, negative 2. And 8, negative 2. So here's my beautiful parabola. My domain is all real numbers. That's where it gets tappy. What's my range? Good. Greater than or equal to negative 10. Because that negative 10 is my minimum. Right? All right.
Are we doing absolute value?
Absolute value.
Is this quadratic? There's another one?
Yes. What happens when my vertex is not a whole number?
You give up.
And it's not 1/2. And so if you make a table, you're not going to see symmetry, and we're going to talk about why and how to deal with that. The parabola is symmetrical, but remember that in order for it to be symmetrical, it has to be the same distance from the vertex. So what's my equation for vertex? Let's not get scared yet, okay?
X equals negative b over 2a.
X equals negative b over 2a. So that's negative 3 over 2 times 2, which is negative 3/4. Okay, so let's look at this on a number line.
It's going to be close right there.
Okay. So it's going to be between 0 and negative 1, but closer to negative 1. We have this distance is 1/4 away, right? 3/4 is 1/4 away from 1. And it's 3/4 away from 0. Right? So if I use negative 1 and 0 in my table, they should not have the same value for the y value because they're not the same distance from the vertex. Right?
Oh, she was just trying to show you like where it's at.
I'm showing you why if I pick whole numbers for my table, I'm not going to see symmetry around it because we're not the same distance.
So we would use fourths.
So you could choose to use fractions in your table, or we can choose to just plug the numbers in, which is what we're going to do. Okay? If I wanted to see symmetry in my table, I would need to use negative 1 and negative 1/2. Because negative 1/2 is 1/4 away from 3/4. Right? And that's confusing to sit and think about because let's be honest, we suck with fractions. So let's just use whole numbers. Okay? But you have to plug all of them in. Because that 3/4 is not halfway between the two whole numbers, okay? So,
I say plug up.
Let's just knock down
so we're going to make our table. I have 0 and positive 1, negative 1, and negative 2. That's what our number line looks like, right? Think about the graph. The whole numbers are around it. And we're just going to plug them all in instead of using the symmetry because then we'd have to think really carefully about what x values we're going to use. And it's only an issue when we have a fraction that's not 1/2. Okay? If it's 1/3, you're going to have to plug them all in. If it's 2/3, you have to plug them all in. 3/4, 1/4, 1/5. You don't get those very often. I don't even think there's one on your homework tonight. But I still want you to see it. So let's start plugging numbers in. We're going to plug in x equals 1. 2 times 1 squared plus 3 times 1 plus 1. Exponent first. 2 times 1 is 1. 1 times 2 is 2. Plus 3 plus 1, 6.
Period, that's awesome. Oh, but now you gotta square 3/4.
That's where.
Wait.
We'll do that last.
Oh.
Okay, what do we get when I plug in 0? 1. We'll do -1 and -2, and then we'll do the fraction at the end. Because even if I was like super mean and I gave this type of problem to you on a test, and you could plug in all the numbers except for that 1/3, your graph's still going to look pretty close, and you get most of the credit, right? I'm still want you to try to do your fractions because we are big kids and we need to know how to do fractions. 2 times -1 squared plus 3 times -1 plus 1. Exponent first, so 2 times 1 minus 3 plus 1. 2 minus 3 plus 1. -1 plus 1 is 0. And plug in -2. 2 times -2 squared plus 3 times -2 plus 1. See, this is what I was talking about. You're not going to get 1 here, right? If you were to complete the other tables and actually plug in the other numbers, you would get that symmetrical, that same number. You're not getting that because we are a different distance from the vertex. Okay? So this is 2 times 4 minus 6 plus 1. Okay, well that's 8 minus 6 plus 1. Okay, so that's 2 plus 1, which is 3. 3. There. Now I did it right. Okay, now for the fraction. 2 times -3/4 squared plus 3 times 3/4. Don't turn your brains off right now. You know how to do this. You have been doing fractions since 4th grade. 4th grade.
I don't remember.
That's 4th, 5th, 6th, 7th, 8th, 9th, 10th. 7 years. You've got to get the fractions down. You can just leave it on my keyboard.
I barely
Yeah.
remember anything.
Okay, so how do I square a fraction? We square the top, we square the bottom. So -3/4 squares is 9 over 16 times 2.
I don't know why I put 2 over 6.
You're just multiplying the number by itself. -3/4 times -3/4 is 9 over 16 plus, put a 1 underneath that 3. Multiply the top, 9/4 plus 1. Multiply the bottom.
Would it be negative?
Yes.
Okay, no, I did it right.
Yes, it would be negative because it's a minus. Okay. Sorry, it's negative.
Oh, wait, I get it now. Never mind.
Okay. Now, can I divide 16 by 2? Yes. So that's 8. So I get 9/8 minus 9/4 plus 1. I'm going to make this a fraction. 1 over 1.
It's all fun again.
So I need a common denominator of
2. 8.
8.
So, 1 over 1 will be 8 over 8.
It's going to be 8 over 8. Yeah.
How do you get 9 over 6?
16 divided by 2 is 8. So I can cross cancel, can cross simplify, because I'm multiplying 9/16 by 2, which would be 18 over 16, which would reduce to 9 over 8. So I need a common denominator. The common multiple of 8, 4, and 1 is 8. So what do I have to multiply 9/4 by to make the denominator 8?
Oh.
Times 2. What do I have to multiply 1 by to make the denominator 8? 8. So we have 9/8 minus 18/8 plus 8/8. Now we just subtract and add the top. So 9 minus 18 is negative 9/8 plus 8/8 is negative 1/8.
That took a lot of brain power.
That's a whole lot for just one little simple thing.
Every time I redo fractions, I can feel my brain start to die.
It's actually growing. It's not dying, it's growing. You're making those synapses. Eventually you will get it. It's growing. Okay,
Now I have to go.
now we have to graph it. It's not that hard. It's not that bad. Relax. Relax. Can you graph negative 2, 3? Yes, we can graph negative 2, positive 3. Can we graph negative 1, 0? Yes. Now, negative 3/4 is right here, right? And negative 1/8 is down just a little bit. So we're going to put negative 3/4, negative 1/8 right here.
Why is it like zigzags?
Huh?
Why is negative 1 0?
Why is it so close?
And 0 was 1, and 1 was 6.
What?
I'm just, look at your table. Oh, 1/6. Hold on, let me move this.
Symmetry.
Look at it. Negative. Why does mine look like that? I don't like this graph.
Okay, so what is making our eyes dislike this graph? It's the lack of symmetry, right? We want the parabola to be symmetrical, but this doesn't look symmetrical. It's all like wonky, like freaking zombie. It's a zombie parabola, okay? But when we connect it, you can see
Still cool.
there's still symmetry here.
Not really.
Just because the points aren't drawn there doesn't mean it's not symmetrical. Your points are looking weird. That doesn't mean you did anything wrong because you don't see the symmetry that your eyes want. Okay, that's why I wanted to do this example with you so you could see it's not always pretty. And that's okay.
Oh my gosh.
Let's go. The key feature for the standard form is the y-intercept. The vertex, we use x equals negative b over 2a, and you have to plug it in to find y. The axis of symmetry is also negative b over 2a. Because the axis of symmetry is a vertical line that passes through the x value of the vertex. The y-intercept is 0, c. We still have to solve. That's chapter 3. This is the same as this. And this is the same. Make a table. Find the vertex, make a table. That's all.